The last thing that I want to do is to do a couple of scientific notation problems using the rules that we've been talking about in this section. So I'm on page 91, and I'm going to do number 18, and then I'm going to do number 22. So I've got 18 and then 22. So an example of multiplication and an example of division. So I'm starting off with 7.2 times 10 to the 9th times 9.4. Oops, 9.4 times 10 to the 8th. And I'm going to think back to the very beginning of these notes when I talked about coefficient and base and power. So the coefficient, remember, was the number we were multiplying the base by. In this case, it's 5. And the base was the thing that we were raising to a power. In this case, it's x. Those pieces of monomials are also part of scientific notation. So the coefficient is 7.2. That's the coefficient. And the base is the 10. So that's a base right here. And of course, the 9 is just the power, the exponent. I could write this as 7.2 times 10 to the 9th. That would mean the same thing. It's written with the little x, right, the little time symbol, just because that's the convention that scientific notation is usually written in. We don't have to write it. It's a little easier, I guess, to see what the coefficient is and to see what the power is, and what when you're doing scientific notation. However, you could write it as 7.2 times 10 to the 9th in this way, and it would be the same thing. All right. Because that's the case, I can use the same rules that I have been using when I'm multiplying monomials with the same base. So I have the same base in both of these. The bases are 10, which means I'm going to be able to add the exponents, the 9 plus the 8. It also means I'm going to be able to multiply the coefficients. So here's my other coefficient, the 9.4. Here's my other base. It's the 10. Here's my other exponent, the 8. So what I'm going to do is I'm going to multiply 7.2 times 9.4, put that in my calculator, and then I'm going to add the exponents together. So that's going to be 10 to the 9 plus 8. That I can do in my head. 10 to the 17th. Done. The 7.2 times 9.4 I'm going to pop in the calculator. So let's see here, I've got 7.2 times 9.4, 9.4, and give me 67.68. 67.68. And that, by the way, is a totally legitimate, reasonable answer. Probably if we check this with an answer key, however, that wouldn't be the answer we would get or we would be given. And that's because 67.68 is not in proper scientific form. We need to have a number that's between 1 and 10 for that to happen. So I'm going to move the decimal point over 1 point here to the left and have 6.768, which means I'm going to need to raise the exponent here by 1. I'll get 10 to the 18th, and that is my scientific notation answer in proper form. Both of them are correct. There's nothing wrong with either one of the answers. You might use one or the other depending on the context, but if it wants the answer expressed in scientific notation form, the 6.78 is the one we want because the coefficient is now a number between 1 and 10. All right, let's try a division problem. I'm going to do number 22. So number 22 has me dividing 1.1 times 10 to the negative 3 by 5.5 times 10 to the negative 8. And once again, I have coefficients here, 1.1 and 5.5. I'm going to divide those and I have like bases. They're both 10s, so I'll subtract the exponents. So in my calculator, I'm going to go 1.1 divided by 5.5. And then I can do the subtracting in my head. It's going to be 10 to the negative 3 minus a negative 8. Right, I'm subtracting a negative 8. So that will be 10 to the negative 3 plus 8, or 10 to the 5th. And I'm going to put the 1.1 divided by 5.5 in the calculator. 1.1 divided by 5.5 gives me 0.2. So 0.2. And once again, 0.2 is not in proper scientific notation form. I'm going to move the decimal 1 point over here to the right, which means I'm going to lower my power by 1. Here's my answer in proper scientific notation form, 2 times 10 to the 4th. So not really important, the scientific notation, multiplication, division piece in this context. Just a good little bit of review. You'll see it again, I'm sure, in a science class and maybe in another math class. Definitely when you're looking at large or very small, very large numbers, scientific notation happens often, and it's kind of nice to be able to combine them easily. And please remember that those answers that I boxed are proper scientific notation form, but the other versions, the 0.2 times 10 to the 5th and the 67.68 times 10 to the 17th, are also correct answers. They're just not in scientific notation form.